And that's your graph. Okay, so for number 30, I've got H right here, K right here, and this is B. So B is actually a horizontal stretch. Even though you see the 1/2, remember it is the reciprocal of B, so it's a stretch, a horizontal stretch. So the two parameters that are affecting X are B and H, and K is affecting the Y. So this is the only parameter affecting the Y. So I can just put +2 up here, and I know that all my Y's are going to be increased by 2. On the X, though, I'd rather just show the step. So remember, it's not 1/2, but 2. 2 times -1. Oops, what happened here? Okay, 2, I'm not going to erase, just think this is -1. H is 1, so we're going to do +1. And then 2 minus 1 for the Y would be 1. And then 2 times 0 plus 1. And then 2 plus 0 is 2. And then 2 times 1 plus 1. And then 2 plus 1 is 3. So the Y's got increased by 2. The X's went through 2 changes, times 2 and plus 1. Okay? So now we're just going to simplify this. So 2 times -1 is -2, plus 1 is -1. 2 times 0 is 0, plus 1 is 1, and then the 2 comes down. 2 times 1 is 2, 2 plus 1 is 3. So these are the points we're going to graph. So we plot the points -1, 1, 1, 2, that's the inflection point, and then 3, 3. So you see here the horizontal stretch. So it went out like this, and then, oops, missed that dot right there. Okay, so for number 31, you have to write the equation for that graph. Now the inflection point, and I know it's really fuzzy, the inflection point is -3, -5. And then the other 2 points were not labeled, but you could figure them out. So this would be -4, -3. Oops, I wrote 5, but it's -3. So I'll just use that one, okay? I mean, you can use -2, -7 if you'd like, but I'm just going to pick this one, and then this is my HK. So g of x is y. So remember, this is x and this is y. So -3 equals, I'm looking for a, x is -4, h is -3, cubed, don't forget to cube, plus k. So k is -5, so I'm going to put -5. So -3 equals, now this gives you -4 plus 3, so that's -1. So that's -1 cubed is still -1, so it's -a minus 5. I'm going to add 5. So 2 is -a. So that means that a is -2. So my function is going to be g of x equals -2 times the quantity of x plus 3 cubed minus 5. And this function is the one that we use to get this graph. Alright, so 2, -1 is the HK. So 2, -1. So the point here is 3, 1. Keep switching pages. So 3, 1 is my XY. And this is my HK. And again, I can use this point if I want, but since you only need one, so I'll just stick with the 3, 1. Okay? So g of x is y, so I'm going to put 1 equals a times x, which is 3, minus h cubed minus 1, because k is -1. 3 minus 2 is 1, 1 cubed is 1, so 1 equals a minus 1. I'm going to add 1, so a is 2. So you write g of x equals 2 x minus 2 cubed minus 1. Okay, for number 33, they wanted with the 1 over b, but we'll find the a first, and then I'll show you how to get it into 1 over b. So let's go ahead and find the a. So I've got the inflection point is negative 1, negative 3. Okay, negative 1, negative 3. And this other point would be 2, negative 2. Okay, so I'll just stick with those two. This is my x, y, and this is my h, k. So negative 2 equals, and again, I'm gonna keep a. X would be 2 minus a negative 1 for h, cubed minus 3. So I'm going to add 3 to both sides, and so I get 1 equals, now this here is 3, so 3 cubed is 27. So I'm going to divide by 27. So a is 1 over 27. Now 27, well, 1 over 27 is a cube number. I can find the cube root of 1 over 27. The cube root of 1 over 27 is 1 over 3. So when I write my equation, this is a and this would be b. Okay, so it would be g of x equals 1/3 x plus 1 cubed minus 3. Now notice how I put the 1/3 in here inside of these parentheses, and then it's raised to the 3rd power, so that's what makes it a b. Had I used 1 over 27, I would have written it like this. I'll put it on the left side. I would have written g of x just like the other ones, like the other two that I did. So it'd be like this. Look at the difference. Right here, the 1 over 27 is not being raised to the 3rd power. Only this is. Whereas over here, I'm raising it to the 3rd power. Okay, so that's why it's inside with the x and it's raised to the 3rd power. That's what makes it a b. Okay, and remember how we got the b? I took the a value, found the cube root, and that gave me my b. They're asking you, I know I told you guys to switch the directions and just sketch the graph. So we're going to take the leading, we need to find the leading term for this. So I'm going to put leading term right here. And why we need this is because we need the end behavior. So I've got negative 2x squared times x, that gives me what's going on? Second time it happens. So negative, let me just write it again here. Just ignore that line. Negative 2x cubed. So this tells me first of all, this tells me that the odd power tells me that the ends are going to go in opposite directions, and the negative tells me that it's going to be an up, down. Okay? So those are the end behaviors. The zeros are 0 and 4. The multiplicity of each one for the 0, the multiplicity is 2, which is even. The multiplicity of 4, well, it's a 0 one time, so that one's odd. So that tells me that here it's going to be tangent and here it's going to cross. So you graph the information you have so far. So we graph the zeros, put them the dots on the x-axis. So I have this here, this here. The end behaviors, again, it's up, down, so I know that from here it's going to go up, and from here it's going to come down. And then I know that at 0 it's going to be tangent, and at 4 it's going to cross through. So then with that information, I know it's going to go like this. At some point it's going to curve back down, and there. So this is a very rough sketch of that function for number 34. And let me just modify this a little bit. I would not label, when you're just doing a rough sketch, I would not label the y-axis unless you're going to plot points and calculate points. So let me go ahead and just fix that. Like that. Okay, because if you plug in a 2, this would actually, point right here would actually go to like 16. So that would be 16. If you plotted 3, that would be like 18 right there. Okay, so it's not to scale. It's not drawn to scale on the y-axis. Okay, 35 is a true or false question, and it says that the inverse of a linear function is always a function. That's true except for one exception. If you have a horizontal line say y equals 2, that's a function, and I found the inverse for that. Remember how we find inverse? We can just switch points. So like, I'm just drawing some dots because we're going to be finding their inverse. I'll change a color. So 0, 2 on the line becomes 2, 0. 2, 2 on the line is 2, 2. 4, 2 on the line is 2, 4. Over here on the left side, on the negative side, negative 2, 2 is 2, negative 2. So see how we're forming the inverse of the pink line? Okay, but this one is no longer a function because it fails the vertical line test. Okay, so this is x equals 2, and it's not a function. So the statement is false because we found one example where it doesn't work. Okay, for 36, they want turning points, domain, range, and behavior. End behavior. Okay, so I know it's missing the word end, but it's the end behavior. So we need to find the leading term. So we take x, x, and x. This is x cubed. Okay, so this tells me that the degree of this polynomial is 3. So the turning points, I'll just put TP, is n minus 1, with n being the degree, so 3 minus 1 is 2. Okay, then we have the domain. It's all reals. Every polynomial has a domain of all reals. Okay, that's how you write all reals in interval notation. The range, I'll hold off on that one for a little bit. And let's take a look at end behaviors first. Now, because it's a cubic function, this is a down up, right? So this is a down up, and you would say, as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to negative infinity. Okay, that's how you would write it mathematically. Okay, and then because the ends go in opposite directions, because it's going to be something like this, then the range is also all reals.